we're now going to look at some built-in list operations. So this first link will show us some built-in mutable list operations. Now, we've seen a lot of these before. For instance, if we say s at position I is equal to x, then it'll replace the element at position I with the value x. However, there's some different ones too. We can do s of I colon j is equal to t. Now what this is saying is that if you have some list, L is equal to 1, 2, 3, 4, 5, and you have another list, let's say t is equal to 0, 1, 2, 3, or let's call it actually 0, 0, 0, 0. And I can say, so if I run this, I can say L of 1 to 3. So basically from 2 till 3, I can replace it with t. So now it'll basically take the list t and put it in replace for L1 colon 3. So t must be another list, and it'll basically insert that list into L. Additionally, you can just delete everything inside of a certain range. So for instance, I can do L of 1 up till 6, and I can delete that. So now L removes everything over here. I can also replace a stepped index by t. I can delete that stepped index. We can append things to s. That'll destructively add it to the end of the list. We can do s.clear. So that'll essentially just delete everything in the list. So if I do l.clear, then L is now empty. L.copy creates a shallow copy like copy.copy. L.s.extend. So .extend is a good one. So basically I have the list L is equal to 1, 2, 3, and I have the list T is equal to 4, 5, 6. So I have the list L. If I do L.append of T, then I would hope that it concatenates them together, but it actually says that T is now an element inside of L. So the list 4, 5, 6 is now in L, which is not what we want. So what instead we can do is L.extend of T. What this will do is essentially say, okay, let's combine the list L with the list T. It's like doing L plus T. However, L isn't changed and T isn't changed. So as the example says back there, we can do L plus equals T. L plus equals T. And this will destructively add T to L. So remember, append appends an element to L, while extend extends a list of elements onto the back of L. We can do S times equals N. So this is also a good one. Basically, we've seen this before. So I'll say L is equal to the list containing 0. If I do L times 10, then it basically takes all the elements in L and multiplies it by 10. So if I do L is equal to 0, 1, and L times 2, it's 0, 1, 0, 1. S dot insert I at position I inserts the element X there. So, for example, L 0, 1, 2. If I say L at dot insert at the position 1, I want to put a 5 there. It's going to basically say that the 5 now must be at position 1, which means that the list will be 0, then 5, and everything after that will shift over. So now if I see it, it's 0, then the 5 is at position 1, and everything is shifted over. If I do s.pop, this will essentially say L.pop. So if I do L.pop without anything, it'll basically print out the last element. That's what the function returns, and then it'll essentially destructively take it off. So this is interesting. Pop is one of the only destructive methods which actually returns something other than none. If you see all the other things we've been doing, like insert, it only returns none because it's destructive, so it doesn't need to return anything. But .pop pops off the last element and returns it to us, as well as destructively modifies L. Now, if we just do .pop, it'll pop off the last element. So if we do L.pop of, let's say, 0, it'll now remove the first element. So we expect the 0 to be popped, and the 0 is no longer there. So we can say pop at a certain index, and it'll pop that index. We can do s.reverse, and it'll basically reverse the list. So I have the list L is equal to that, L.reverse, and now it's 1, 5. This is similar to like if we wanted to non-destructively get the reverse of the list, we can do L ::(-1), and that'll reverse it, but it didn't modify it. So These are different ways that we can destructively mutate lists in different methods. Now, the other link on this set of notes basically takes us to some different methods which you've already seen. The only ones that we haven't seen here is the list.count and the list.sort. So we can go over them really quickly. So L is equal to 0, 0, 1, 1, 2, 2, 3, 2, 3, 3, 3, 0, 0, 0, 1, 1, 1. So if I do L.count, I basically give it the element I want to count. So it says that there's 1 0. Now what about 1? There's 6 ones. And let's say, ask how many times does the word rohan appear in here? 0 times. So L.count works exactly as how you would expect it. It counts the number of occurrences of the element you give it. Then L.sort is the destructive way to sort a list. So I have the list L. If I do sorted of L, then it'll return a sorted list, which is the sorted version of L. However, the original L is not modified. So if I do L.sort, it doesn't return anything, which should cue us into the fact that it's destructive. And then when I now print out L, it now shows the sorted version of L. So that's how we destructively modify a list. Make sure that on your homeworks and when you do practice problems, you don't assume that L.sort returns anything, because it doesn't. It only destructively modifies the list. So these were some built-in operations and methods we can do with lists, and you'll basically use a lot of them while doing different problems.